question 1, please. How are you guys doing? You guys okay? Yeah. The rest of it. Right, guys. All right. Since I haven't done any questions like this, I want to do question 1. All right. I want to show you how to do question 1, guys. So maybe you can do the others for yourself. I'm really disappointed with the number of people coming to this class, guys. I don't know why there are so few coming. Anyway, right. So the question here is that you're testing for p equal to this versus p not equal to this, where p is the proportion of defectives. And y is the number of defectives in a bag of 20. And we reject the null hypothesis H0 if this or this happens. Now, can you tell me, all right, the first question is to find the power function at p. Remember from last week, guys, the power function is the probability of rejecting H0 given the value for p. Yeah, this is how we defined this last week. So this is the same as the probability that y is greater than or equal to 7 or less than or equal to 1 given p. Now y greater than or equal to 7 could mean it could be 7, 8, 9, 10, etc. So what I'm going to use here is I'm going to use the complement rule. You know, by the complement rule, this probability is 1 minus the probability of the opposite of this event. Now, can you guys tell me what's the opposite of this event? That y is greater than or equal to 7 or less than or equal to 1 means that y is between 2 and 6, right? Remember? You guys follow me? Yeah? The opposite of this event, that y is greater than or equal to 7 or less than or equal to 1, is y is between 2 and 6 inclusive. Right? Now, this is the same as saying this is the same as this, guys, right? If y is between 2 and 6, it can take 2, 3, 4, 5, or 6. So I from 2 to 6 of this. Now, Now let me ask you, what distribution will y have? Remember, y represents the number of defectives in a bag of 20. So what distribution do you think it will have? I'm sure you've done an awful lot of this. Huh? Come on guys, please. What distribution will it have? It is geometric, negative binomial, Poisson. Which of them do you think? Yes, binomial, right? Because remember, we have a bag with 20 items. So each item is either defective or non-defective, and that y is the number of defectives. So y must have a binomial distribution with parameters 20 and p. So this is simply 20. Choose I. Yeah. So this is the formula for the power function. This is the formula for the power function. And the question also asks you to work out, find pi of p at p equal to 0, 0.2, 0.4, 0.6, 0.8, and 1. And all you have to do is that just sub these numbers into this formula and work out what pi of p is, right? Okay, and finally it is asking you for the level of significance, which is, remember, the significance level. I think I mentioned this last week to you guys. The significance level, do you remember this guy? What did I mention? What did I tell you guys last week? Significance level is the same as alpha. Now what is alpha? The probability of type 1 error, yeah, which is pi at, remember the probability of type 1 error is pi at theta 0, which in this case is 0.2. So it's pi at 0.2. Remember, we are testing this versus this. So the significance level is equal to pi at 0.2. Okay, so you just need to work this out at p equal to 0.2. All right, is that clear, guys, or no? Yeah, you can. If that's clear, can you do question 2, guys, please? I just wanted to show you how to do this because I haven't done any questions like this before. You're also, yeah. Rose is happy. Yeah. Sorry, can you guys do question 2, please? Can I have a question? Are you guys doing all right? Oh, this is the random model. Is it easy? Not easy. You're good. Anybody who hasn't signed this paper, all this paper, both are the same. Guys, could you please do question 2, guys? Well, it's not the same, but it's the same procedure. You just need to apply the probability of accepting it to your H1, H2. So it's the same procedure. You're right, guys. You're right. All right, guys. Shh. Can you guys listen if you haven't done question 2? So you have x is a geometric variable with parameter p, and we are testing the hypothesis that p is equal to 0.1 versus the alternative hypothesis that p is equal to 0.2, and we reject the null hypothesis if x is less than or equal to 5. Now you are asked to find the type 1 error, the probabilities of type 1 and type 2 errors. Now the probability of type 1 error. Do you guys remember from last week what is type 1 error? Is the probability of rejecting H naught when H naught is true, right? Which is the probability that x is less than or equal to 5 when p is equal to 0.1. Okay, now we know that x as the geometric variable, right? So this is the sum of the probability that x is equal to I from 1 to 5. Right, remember geometric variable takes values from 1, 2, 3 up to infinity. So if x is less than or equal to 5, it can be either 1, 2, 3, 4 or 5. Okay? So this is the probability that. Now you guys, if you look at the lecture notes, guys, you will know what this formula is. Is P, which is 0.1 times 1 minus 0.1 to the power I minus 1. So this is the answer to the probability of type 1 error. You know where this formula comes from. It's from the, if you look at the lecture notes, guys, if you don't have a copy, I have a spare one if you want to borrow a copy. Yeah. Right, and the probability of type 2 error remember, guys, the probability of is the probability of accepting H0 when H1 is true. So this is the probability 1 minus the probability of rejecting H0 when H1 is true, right? This is by the negation rule. So this is 1 minus the probability that x is less than or equal to 5. Now H1 is true if P is 0.2, right? So this is 1 minus the probability that I is from 1 to 5 of the probability that 0.2 times 1 minus 0.2 power I minus 1. So that's it, guys. So it's not difficult, is it, guys? Yeah. Yeah. Any questions, guys? And you do question 3, guys, if you're okay with this. Guys, could you do 3, please? Question 3. Question 3 is not very similar. You okay? Oh yeah, obviously you need to use selection on space. Do you have the mouse? This is where this was the first, right? So this is like this one, this one, right? So under the alternative 3 to 4, which is greater than mu 0. So the rule is, this is the rejection rule. This is the rule for rejection. You can hit it. Guys, to do question 3, you need to use selection arts. Guys, I want to tell you, everyone have you brought selection arts? Got some space in my office. Somebody has to go to my office to fix the space. Yeah. Sorry guys. You have a copy of this, man? Oh, you got it there, man. Good. Can you guys look at page 20? You need to use this formula, equation 95. Guys, look, listen. You need to use this equation 95 to do question number 3. Yeah? So if you don't have a copy of the notes, I can give you this. Well, I can give you this as a present. And take this one. No? No? Yeah. But this one is more appropriate because the question here, it says before is greater than 0, yeah? So can you look at equation 9.5? That's the rejection. It gives you the rejection rule for question number 3, guys. Oh, sorry. Is
this rejection rule applies to all the cases?
This one?
Yeah.
Yeah, it's only when you have like a hypothesis like this, mu equal to mu 0 versus mu greater than mu 0. Yeah. Anybody wants a copy of this for free? You can have it. Yeah. All right, guys, let's see how we can do this. Guys, could you listen, please? Now you have a random sample from a normal distribution with these parameters. Yeah. and we are testing this versus this. The rejection, we reject the null hypothesis if, according to equation 95, root of n divided by sigma, which is 2 times x bar, is greater than or equal to z 0.05. This is by equation 95 in the lecture notes. Do you guys say this or not? This equation applies, guys, because if you look at the null and the alternative, under the alternative 4 is greater than 0, right? 0 is the value under the null hypothesis, 4 is the value under the alternative hypothesis. So you can see the value under the alternative is greater than the value under the null. So that's why we are using this equation 95, right? So this is the rule for rejection. And the question, guys, is to find an expression for type 2 error. So we want to find the probability of type type 2 error, which is the probability of accepting H0 if mu is equal to 4. Yeah. Now this is the rule for rejecting H0. Now so we will accept H0 if root of n divided by 2 right? Do you guys understand this or not?
Yes.
Yes, of course. I maybe asked you guys too many times. Right. Now the true population mean is equal to 4, guys. Now in order to use the rule that I used last time, I'm going to subtract a 4 and add a. You will see why I'm doing this in a minute, guys, because you see I have for a purpose I have a minus of 4 and a plus of 4, and you see why I have done this in a minute. Now I'm gonna take this second 4. This guy here, I'm gonna take. Oh man, I'm gonna take this second 4 to this side here, right? So that's gonna become 2 root of n given. All right, now let me ask you. This is this is a question I asked you last week a couple of times. I think some of you still appear confused about this. Now, tell me the distribution of this is, because the true population mean is equal to 4, right? So I'm subtracting 4 and multiplying by this. Now we know that x bar will have the normal distribution with 4 and 4 by n. All right. This is from a result that I did in week 1 or 2, right? Now if you subtract the 4, the mean will become 0, and when you multiply by this, the variance will become 1, right? So this is the same as the probability that n01 is less than, I don't know, some of you still appear confused. I don't know. You have to. This step here is crucial. The step from this to this, the last step, is very, very crucial. And even today, some of you ask me this question: why it goes from this to this? But just think about it, guys. Think about it, guys. Right? Because by a result that I did in week 2, this x bar has this distribution. You should subtract a 4, the mean will become 0. You should multiply by this, the variance will become 1. Yeah. All right, so that's why you get this N01. So the answer is phi. So this is the answer to the question. So this is the probability of type 2 error. Okay. Is that clear, guys? Yeah. Yes. All right. Can you do question 4 if this is clear? Yes. Yeah, that's because I said because under the given hypothesis, it says mu equal to 4, which is greater than 0. Yeah, that's why I use this one, not this one. Yeah. You understand that? Because under the alternative mu is equal to 4, under the null mu equal to 0. 4 is greater than 0. Yeah. Are you guys okay with that or not? Yes. No? Why is it? You said no. Why is that? Where you got lost? You don't like it that much? Ah, come on. You got that, right? Come on. What about you, sir? You follow? You drop? No, that's the simple formula. That's the simplest you can get. Come on. Yeah. Yeah, this is the same as this one. Yeah. X bar minus mu divided this is what you have here. That's how you, which step you don't follow? You mean this is the same, right? Yeah. Yeah. I mean this is the same as this one. Yeah. Yeah. Minus 2. Because the 2 comes from here. When you divide 4 by 2, you get 2. That's why you get the 2 here. Just think about it, guys. It's not difficult. It's not rocket science. Yeah. Think about it, man. No, because it's sigma squared by n. There's no L squared here. If you look at the election notes on page 2, week 2, you see it says mu comma sigma squared by n. Not L squared here. This is mu comma sigma squared by n. Are you guys confused too? Or no? Little bit. Which part is this one? Okay. Yeah. Guys, look. I mean, some of you are asking me where this came from. This is stuff we did in week 2, guys. Well, you're not here on week 2. Maybe you forgot. I don't know. I thought you guys have better memory than I do. Remember, like, if you have, do you guys know this result that if x1 to xn, have IID with this, with the normal distribution, right? Then x bar is a sample mean, also has a normal distribution with these parameters, right? This is the result. This is the result I have used to get this, guys. Do you remember this result? Seeing this before? No? If you have a random sample from a normal, then the sample mean also has normal with these parameters, guys. You haven't seen it before? It's on page week 2 of the notes, guys. We did this in week 2. And this is the result I have used to get this. Yeah? No? Just think about it. Spend some time on my course, guys. I know you had midterms or from other courses. Maybe you're not focusing enough on my course. Yeah, I think you should spend more time on my course, guys. Right? Yeah. So maybe you see how I got this. How I got this, guys, using this result. If you look at the lecture notes, guys, you will see this result, right? And I've used this to get this. Yeah. All right. All right. Can you now do question 4, guys? I know we're running out of time now. Can you do question 4? Are you lost too? Okay, that's good. How are you guys? Are you guys okay? How are you? You asked me a question about that. I think it's somebody else. All right, guys. I really think you should spend more time on my course because revising the course, guys. I think that's why I do all these examples to help you to learn, guys. You know, you learn by examples, guys, not by reading books. All right, question 4. Guys, now in this case, when would you reject H0? Did you listen, please? In this case, what's the rule for rejecting? You should look at equation 92 on page 20 of the notes. You will see, right? The rule for rejecting is root of n divided by sigma, which is 2 times x bar minus 0 greater than z alpha by 2, right? This is the rule for rejecting the null hypothesis. Now the question in question 4 is to find the power function. So we want to find the power function at mu, which is the probability of rejecting H0 given the value for mu, right, which is the probability the root of n by 2 times this greater than z alpha by 2 given the value for mu. Now tell me, guys, now I've done a number of questions already. How would you go from this step onwards? What's the next step, guys? You have an absolute sign here. Do you know how to remove the absolute sign? It means right? Do you see what I've done, guys? This is the same as this, right? Either this is greater than this or less than the minus of this, all right, which you can write it as, since these are mutually exclusive events, you can write You can write this as the sum of two probabilities. Right. The reason you can do this is because these two events are mutually exclusive. The term you must have heard that 100 times in your probability 1 course. Yeah. Right. The next thing to do, guys, is because the true population mean is mu. Do you guys understand why I'm doing this, guys? Guys, listen. Why am I doing this, guys? Because the true population mean is equal to mu, right? And the reason I'm doing this is because I want to use the standard normal argument, right? Right now, I'm gonna take this term to the right hand side and take this term to the right hand side, right? So that will give you guys right now, guys. Now tell me, guys, what can you say about this guy and this guy? These two have the standard normal distribution, right? The same argument I applied already twice today, right? This one has a standard number, this one has a standard number. So this is the probability that NO1 is greater than, I can remove the conditioning. We don't need the conditioning anymore because we have used it effectively in this step. All right, and the final step is you can write this as 1 minus phi at z, and you can write this as plus phi at minus You guys with me or not? Does it make sense, guys? Or are you making you more confused? How long have you looked at it? I don't know. What is it? Are you guys following this or not? Are you serious? Alright, sir. You following that? You see? Come on, guys, spend more time on my course, guys. Yeah. Are you guys okay with that? Yeah. All right, can you do question 5, please? Question 5. How you guys? Are you okay? Alright, to do question 5, you need to use another formula from, I would give you a hint. To do question 5, guys, you need to use equation 98. 9-8. You have to use equation 9-8 from election odds, right? That's to do question 5. Yeah? And try and see if you can do it. Now I need to get started moving. So I'm an old man, it takes me 10 minutes to walk to the lecture hall. So I'll see you guys in a minute. So can you work on question 5 now, please?
Example sheet 5, 6. 6 is Jackson. 6 is about 2 questions. We're still in a lot big. I feel like we'll all be doing good community questions.
Yeah.
There'll be loads of studios. Yeah. And on these assurances.
Say insurance.
There'll just be loads of them.
Say loads of insurance is big.